Okay, let's have a good morning. Today we're going to continue our discussion on the use of Excel to compute for time value of money problems. Now, last time we started this discussion by looking at the formulas for future value and for present value. We said that the process of getting the future value is called compounding. And then the process of getting your present value is called discounting. Okay. All right. So compounding and discounting. Compound factor is 1 plus your R raised to the T. Okay, that's our compound factor. On the other hand, our discount factor is 1 over 1 plus R raised to the T. So this is our discount factor, which is also equal to 1 plus R raised to the negative T. Okay, so this is the compound factor. This is the discount factor. All right, so we had some examples last time. Okay, I'm not sure if this was the file that we used. Have we answered this, class? This one? This D12? Kindly chat, please, if we have answered that. Okay, yeah. Sorry about that. Let me just key in the answer. So we're looking for the future value, right? We are compounding. So using Excel, okay, the function is FB. The rate is 12%. The number of periods is 30. Okay, since this is not an annuity, we can just ignore the PMT. And the present value is at 1,000. Okay, for the type, we ignore it because the type refers to the PMT or to the annuity. And this will give us a negative value because the present value is at positive. So Excel is quite particular about the direction of the cash flow. If this is positive, then that means we loaned an amount. Money came in. So what happens after 30 years? We will have to put out money. Money will go out. That's why it gives us a negative answer here. Okay, negative 29,000. So as discussed last time, we're not really interested in whether it's a loan or an investment. What we're interested in is the equivalent, okay? Equivalent value. So what does this tell us? 1,000 today is equivalent to 29,959 after 30 years if it's earning at 12%. So these are just equivalent values, which means if I, for example, if I plot this, okay, so now we have 1 million. Then, so this is 2, 3, I'm sorry, this is 0, 1, 2. This is our timeline up to year 30. Okay, earning at 12%. Okay, this amount is equivalent to 29.959 something million. Okay, so this amount and this amount are equivalent. Only that they of course they come at different time frames, but they're equivalent. So in other words, technically we will be ambivalent or we will not be. It doesn't matter whether we choose 1 million today or 29.959 million after 30 years at 12%. We will be ambivalent to that. Okay, whether we choose 1 million today or 29.959 or 96.6 million after 30 years, it's fine. No? It's fine. Okay, assuming that all things will be the same, 12% all throughout, and not no very extraordinary events happening between now and 30, year 30. Okay, so same thing here. We already did this last time, but let me just, okay, I think we didn't answer H12. Did we, class? Kindly chat, please, if we answered H12. Okay, no, we did not. Okay, so let's answer this question. How long? How long will it take the money to double? Okay, how long will it take the money to double? Okay, so here we're interested in the number of years. Okay, same percent. And then if your money is to double, how much will it be? So it will be 1 million times 2, right? How long will it money to double? So, okay, let's write that. Future value, let me put negative here. Future value rate at 12%, comma, N per is, let's leave it blank first. And then PMT, we don't know, not part of the question. And then PV is 1 million. Okay, so this was our usual FV function, right? And it gives us 1 million because our year here is 0. Okay, we didn't put any value here. So it means that Excel read this as 0. Now what we can do is we can experiment. What if it's 1 year? Then our money will be 1120. So not yet. No? We want it to be 2 million. Okay, how much do we want this to be? We want the money to double. Okay, we want the money to double. So 2 years, no? 2 years, no? So we can do this manually until we get to, let's say 7. Oh, it's over. So it has to be between 6 years and 7 years, right? Because if it's 7 years, then our money became 2.21 million. It's already in excess. But for if it's 6, then it's still lacking, right? Okay, so there are several ways to determine how much our money will double. But let's just use one of the functions in Excel. So if you go to data, and then there's a what if analysis here. Okay, kindly chat please if you see under data the what if analysis. Okay, let me wait for you. Kindly chat please if you got the, if you're able to see the what if analysis. Okay, thank you. Okay, how about the rest? You go to data, and then here in the work forecast ribbon, you have here what if analysis. Okay, the others, how about the others, please? I don't think half of the class responded to that query. Okay, good. Thank you. Thank you. Okay, so we're going to make use of a function of Excel, this one, what if analysis. Okay, if we click this, okay, so you have three functions there: scenario manager, goal seek, and data table. So we're going to make use of goal seek. So let's click this, goal seek. All right, so if you see here, there are three uh, items here that we need to fill up. Now you can see here the arrow sign, or maybe in your case, it's a spreadsheet sign. That means this symbol tells us that we have to link it to our model. Okay, we have to link it to our model. All right. So what do we set? Set cell. What do we set, guys? We want this to be 2000, right? Okay. So we want this cell to be how much? to be to be 2 million, right? To value 2 million. 1, 2, 3, right? Notice that here you have to type it because there's no icon here. Okay, this is not linkable. These two are linkable. Okay, and then by changing what cell? By changing this. So we want Excel to be iterating this so that this one becomes 2 million. Okay, so I'll give you a few seconds to follow along. And kindly chat your answers, guys. Did you get the answer? Kindly chat, please. May I know what values did you get? 6 point. Thank you, Christine. 6.116 years. Yeah, Marian, thank you. How about the rest? Did you get 6.116? Medyo magkaiba si ano, no? 255,374,374,174,71. A little difference between the answers of Marian and Christine. How about the others, class? Okay, Gerard. Medyo iba yung answer ni Christy, ano, no, Marian. Marian, could you kindly check your answer? Kasi dapat pare-pareho tayo. A few decimal placing differences. Okay, the rest, waiting for the more than 15 to please key in their answers. Only 3 were able to follow. Maizen. Okay, so okay, so some answers are the same, some answers are different. So let me check. All right, let me close this first. Again, we're asking Excel to solve for this. Actually, there's a direct way to solve for that, but we'll do that later. But we're just using one functions in what if analysis, the goal sheet. So we're interested to know, okay, our money today is 1,000, and we would like to know in how many years will our money double. So this one, it's a formula. It's a future value of this one is your rate, 12%, and then your NPER, it's blank at the moment, we don't know, and then your PV is 1 million. Okay. If this is 0, then that means your money did not accumulate because it's still year 0. Okay, so 0 years of accumulation. So it will still be 1,000. But we want this one to become 2 million. Okay, we want this 2 million by changing this one. So what should this be so that this one becomes 2 million? That's how we use the goal seek. So going to what if analysis, goal seek, set cell, this one to what value? This one I have to write, I have to type because it's not linkable. So 2, 2, 1, 2, oops. 1, 2, 3, 1, 2, 3. 2 million. And then by changing what cell? So what cell am I changing? I'm changing this one. So I want Excel to keep on changing this so that this one becomes 2 million. So, okay. All right. Okay. So this is, if I increase this one, okay. So if I increase that number of decimal places, this should be the answer. Uh, I don't think it should be any other answer because exacting computation and 2 million. 6.11625537418357 and so on. But this should be the digits. I saw other digits a while ago. Any for the others who had seem to have different answers, could you kindly check? Are there questions about this, class? Maxine seems to have a different answer. And also, si Marian din. Okay. Marian, what happened a while ago? 741. Is it the same? 74, well, okay, 7418357. 741, si break kaninan. Okay, how about mixing? Okay, Or do I have people share their screen? Nasaan na ba yan? May I request Maxim to share your screen, hold the line? Or do I allow people to? Saan ba siya, guys? Yung pag-share ng screen. Can't find it. Saan ba yan? Not that one. Okay. Who can share all participants? Okay. All right. Is it okay for you to share screen? I just want to find out or figure out why you are getting a different answer.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Okay, let's see, guys. Let's see how we can, if we can decipher. All right, could you please show H12? H12, please, first. Close the goal seek first. Okay, may I see your form? Okay, H11, H10. Okay, so it's correct. Okay, your formula there is correct. Okay, so let's go now to data. There, what if analysis? Set cell H12, that's correct, to 2 million by changing one cell. So that's H10. Okay. 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 Interesting. Yeah, your process is correct. Okay, but we're getting different answers. Okay, anyway, they're very, very small numbers. So they're actually immaterial. But I was just curious why. I thought you had something wrong with your process. Yeah, you're correct. The process is correct. However, we're getting a different answer as compared to your answer. Okay, anyway.
Yes, sir. We have different.
Yeah, anyway, those decimal places are really insignificant. Okay, so let me flash again my screen. Thank you so much, Maxine. Thank you.
Thank you, sir. Thank you, sir.
Okay. All right. Do you have other questions? No questions? Okay, so let's continue. So I'm sorry, guys. I think I opened the wrong Excel file. This was from the other section. Okay, have we done B19? Yeah, I think we're done with B19. In fact, I think we're already here, right? B34. Yes. Okay. All right. So just a quick review. I'm sorry about this. I opened the wrong Excel file. Okay. So this time, to compute for the present value, we are actually discounting. And since this is just a review, okay. So let's use the formula first. For the discounting, you have your future value, and then you multiply it by the discount factor 1 plus your rate, okay, and that's raised to the negative t, okay, negative t, okay, 20 years. All right, so this is the formula. So I'm getting 1 million. Okay, that's a formula. But if we're going to use Excel, you have PV. Okay, PV and the rate is the 12%, comma, NPER is 20, comma, PMT ignore because this is not an annuity, and we're given the future value, this one. Okay, type again, ignore because this is not an annuity, and we expect to get negative 1,000 because again, Excel is very particular about the direction of the cash flow. If one is positive, then the other has to be a negative. So since we're not interested in whatever type of transaction that this is, we're just interested in the equivalent value, then I'm just putting a negative sign here, okay, outside. All right, so this is 1,000. So 1,000 today is the same as 9.646 million, okay, at 12% and at 20 years. Okay, of course, if you change this, any of this, then the values will be different. Okay, so that's what we do with the discounting. All right, next, which is what we did last time. Okay, please correct me if I'm wrong. Were we able to answer this B34 and B35? Kindly chat, please. Were we able to answer B34 and B35? Okay, yeah, thank you. Yeah, sorry about that. So we were looking at an annuity last time. Okay, just a quick review. An annuity is a uniform stream of cash flows. Okay, it's a uniform stream of cash flows. Okay, for example, for this one. Okay, we have a payment. When you say payment, this is the annuity payment, 30,000. Interest at 10%, number of payments, 30. Okay, and it was illustrated here. Okay, so let me just show this. There are two types of annuity. You have annuity ordinary and annuity due. So what's the difference between the two? So for annuity ordinary, okay, so this is at 30,000. I'll just put it at 30. The cash flow starts at the end of the first period. So this is the first period, at the end of which the cash flow starts. On the other hand, for an annuity due, okay, the cash flow stands immediately at the beginning of the period. Okay, so for this annuity, all right, you have both 30 for your cash flows, 30 years of 30. Okay, so same number of 30, but the other one starts immediately and ends before the end of the term, right? 30. The other one, on the other hand, starts at the end of the period and up to the last. Okay, but all of them both have the same. All of them both have the same 30. Okay, so the question here is, how much is this stream of cash flows? This 30, 30, 30. How much are they today? Okay, all of them. What's the equivalent value today? Okay, so how do we compute that? There are several ways to do this. First, we can get the present value. Okay, so how much is 30 after 1 year? How much is it now? Okay, so that's a question. Now take note, we cannot add 30, 30, 30, 30. We cannot do that because they all belong to different time frames. So what we can do is to get the present value of this. Okay, present value of this. So if we use the formula, so what's the formula? This is our future value. We want to get its value now. So the formula is the future value, right? And then the present value is times 1 plus. Okay, we were not given the rate, sorry. Let me just, the rate is, copy this, Control C. Let me put this here, okay? All right. So using the formula, this is the future value times 1 plus the rate. So this is the rate. And I'm going to fix this, okay? F4. You recall this, guys? I'm going to fix this so that anywhere I copy this, it will remain at, at S12. And then raised to the shift 6 raised to the first power. There you go. So this is the equivalent of 30 after 1 year. How much is it now? It's, oops, it should be negative, sorry. Negative because the present value, we're discounting it, so that should be negative. So the present value should be lower. Let's just peg it at 1 decimal place. Okay, and I can just copy this. Okay, so you notice, guys, that 30,000 in 30 years time, how much is it equivalent now? It's just 1. Okay, so these are the present values. Okay, these are the present values. And since they're now present values, we can now add them. Okay, so we added them and we got 241.7. Okay, let me pause and then kindly follow along, please. Okay, and then let me show the formula here. And then copy to the right. And then take note that they are all converted to present values. And thus we're able to add them. And once you're done, kindly please chat so that I know if I should continue already. Please chat if you got 241.7 as the present value. Okay, good. Patricia, Christine, thank you. Let's wait for the others. Bianca, thank you. Please direct your answers to everybody, please. Good, Lisa, thank you. Let's give our classmates some more minutes to work on the model. Okay, Yung, thank you. Edwin, thank you. So you should have gotten 241.7. Okay. Okay, good. Gerald, thank you. Yeah. Yeah, that's correct, I think, because this was rounded to, yeah, that's correct. A few more seconds for the others. Okay, any more answers? Not half of the class answered. How many answered? Only 8, not even half of the class. How about the rest, guys? You have any questions? You have any problems with how to work on it? Because you're 22 here and I'm only getting 8 answers. Okay, please direct your answer to everyone. Thank you, Fiona. So let's give a few more seconds to your classmates. Okay, good. Thank you. Thank you. So I wonder why less than half of the class only answered. Is there any question, guys, that you'd like me to address? Any confusion that this might have been causing you, please? Feel free to raise your hands, please. Is there any question? You have to understand what's happening and you have to know how to model this, because in our exams, of course, since we're fully online, okay, so this is what the equivalent 30,000 every year for the next 30 years is equivalent to 241.656 thousand. Okay, so they're equivalent. 30,000 ordinary annuity is the same as 241.656, assuming the rate is at 12%. Okay, 30,000 for the next 30 years. Okay, and also we can use the PV function because we're getting the PV. So let me put already negative PV here, because I know it will give us a negative answer. What's the rate? 12%. And I'm going to fix this. F4. What's the N per? Okay, so this is variable, comma, PMT is this one. Okay, ignore the type. Remove the dollars and then copy this to the right. You see, you'll get the same answer. Okay, so exactly the same. So of course, when we add, we'll get the same answer. All right, now quickly here, how about for an annuity ordinary? Okay, for an annuity ordinary, so the Excel formula, if we're going to get the, okay, I think we should introduce one. Okay, let me move this. And I'm introducing one because we have to sum this up. Okay, so to compute for the present value of 30 using the formula, so it's equal to the future value times 1 plus the rate is at 12%. We're going to fix this. Okay, caret the negative t. Okay, so we start with immediately times 0, and we expect that to be 30. Why? Future value times 1 plus the rate R12, sorry, should be S12. S12, yeah, it moved because I inserted a S12 raised to the negative. Okay. All right. So these are now the present values. And then if we sum this up, so the present value is 270.7. And as expected, it should be higher than ordinary annuity. Okay, annuity due will always be greater than the present value of annuity due will always be greater than annuity ordinary. Why? Because the cash flow immediately starts. Okay, so we have here a 30 is already the present value since it's happening now. Okay, or we can use the formula. Again, it's just the PV formula. PV, and then our rate is the S12. We could have given that a name to make it easy to access. Rate N per is 0. Okay, PMT is, do not ignore that, and then future value is 1, is 30. So you're getting the same. You're getting the same, and then we just add it. Okay. All right. So one thing we can see here, that annuity ordinary will always be less than annuity due when you're getting the present value or the future values. Because of the nature, the cash flow starts. No? Here, the cash flow starts immediately at tier 0. Here, the cash flow starts at tier 1. Okay? If we're given a scenario, and then it does not indicate whether it's annuity ordinary or annuity due, always assume that it is annuity ordinary. Okay, in the absence of any qualifier, always assume that the cash flow is annuity ordinary. Okay, let me pause for a while. Kindly, I have your chats, please, if you were able to get the present value. Excel function for annuity due. Which one here, Patricia? No, not here. Okay, so let me clarify that. I think I know what you're getting at. Here, we're not just using we're just getting the present values. Okay? What we're doing here is we use the long cut. We just got the present values. And we're using the time. This is 0, while this one is time 1. Okay, so after this, we're going to automatically compute for the present value. Okay, all right. So clear now. Let's postpone the use of NPV function. We'll use it later. Let's go back here to our problem. Okay, so this is the same problem. Okay, we have 30,000. We just represented it by 30, and then the interest rate is wait, what's the interest rate? Okay, we use 12% here. So let's change the problem. Let's kindly change this to 12% so that we can compare 12%. Okay, so I think this is a question of Patricia. All right. So how did we compute for the present value? Let's first use the formula here. The formula here is this one. The annuity P times 1 minus 1 plus R raised to the negative n over R. So if we follow that formula, the annuity is 30,000 times the quantity 1 minus 1 plus the rate is 12%, right? And then raised to the negative n, which is 30. Close this. So that takes care of the numerator divided by the rate, so which is this one. Okay, so we expect to get how much did we get this? 241.6. You should be getting that. 241.6 there. Okay, so this is using this formula, present value of an annuity. Okay, and formula text. Okay, just to show you. Okay, so this is the formula for this, using this. Okay, using that. Now we can use the Excel function. Okay, so this is where the question of Patricia a while ago comes in. So we're computing for the present value. So let me put a negative here because okay, we want the answer to be positive also. What's the rate? The rate is 12%, comma. Number of periods is 30, comma. And here we can use now the PMT. Okay, the PMT refers to your annuity. So this is an annuity of 30, comma. Future value, no future value, because your cash flow is 30,000 all throughout. Okay, and then here is the question of Patricia, the type. So end of the period is annuity due. Beginning of the end of the period is annuity ordinary. Beginning of the period is annuity due. So if I want it ordinary, I can type 0, or you can just disregard that. If you disregard that, if you don't put anything there, then Excel will read that to be 0, which means ordinary. So if okay, so you have the same answer. Okay, 241,655.52. This is annuity. This is the present value of annuity ordinary. Okay, however, if it's annuity due, we should be getting this amount. Should be getting 270.7, this one. Okay, so before I go there, class, so let me pause for a while and please tell me if you were able to. So this is the function for this one. Okay, let me pause for a while and then wait for you to chat, please. Now, Patricia, did that answer your question? Except for this one, hindi pa natin nasasagot. Okay, first, nakuha nyo na to? Were you able to show that indeed the present value is 241655, which is the same as the answer when we did it manually? So I'll wait for your responses. Kindly chat, please. Yes, thank you. And thank you. Good. Okay, good. Let's give your classmates a few more minutes to follow. I understand this is quite difficult because you're watching, and then I will have to stop for you to be able to do it. Unless you're having, I don't know, what are you doing, guys? Are you using your mobile phone and then your laptop at the same time so that you can watch and then follow along at the same time? What's your setup, guys? Are you watching the video through mobile phone and then following along in your laptop's Excel? Because I'm pretty sure that you're not following along sa mobile phone, using Excel. It's difficult to use Excel, especially these functionalities. So the rest, please, guys. How about the rest? Okay. So thank you, Fiona. Again, share your answers, please, to everyone. Fiona daw naka-minimize si Excel, tapos naka-zoom. Tapos kailangan nyo nga talaga pag ganong situation, I will really have to stop for you to be able to follow along. Okay, for others, how about you, Diana? Are you using your cell phone and your mobile at the same time?
No, sir. Just split screen.
Okay, sige. All right. So, Kristen, kindly share your answer, your question, please. Please share your question to the others. Yan. Thank you. Okay, sige, I'll stop sharing, and then kindly please share your screen. I think I know where your error is. So let's see the screen, the Excel work of Christine. Okay. All right, Christine, kindly flash yung. Okay. Nakaano ka ba? Ayan. So, please press F2. F2, yan. So, kita natin yung formula dyan. No? So that's B31, that's 30,000 times 1 minus 1 plus B32 squared. Okay. To the negative B33. Okay, tama yan. But you have to close first. Yung parenthesis mo dapat after B33. Yeah, tapos tanggalin mo yung parenthesis sa B32. 282. Ginawa natin kasing 12% yung interest. We changed the interest to 12% kasi yung nang ginamit natin kanina. Okay, kindly change the interest. Dito sa yan, make it 12%. Yan, okay na, no? Okay, did that answer your question? Okay, good. Thank you.
Thank you po, sir.
Thank you, Christine. I appreciate your questions, class. No, please do not hesitate to ask questions because it's part of the learning process. No? Your questions could also be could be learning experience also for your classmates. Okay, so clear na itong 241,655, no? And then let's show now how to get the present value of an annuity due. So it should also be negative PV. We're using negative so that the cash flow will just be positive. No? Ang rate natin is 12%, comma, NPER is 30 years, comma, PMT is 30, comma, and then the future value is none. And then dito na guys, no, dito na magkakatalo. No? What type of annuity do we have? It's 1. It's at the beginning of the period. So 1 yan. Okay. So that's 1. Control enter. So we now have 270. So I'm flashing here the formula para kitang-kita nyo kagad. Yeah, so this is annuity ordinary. This is annuity due. 1 yung ginamit natin. So the present value of the annuity due will always be bigger than the annuity ordinary. Kasi immediately yung cash flow niyan. So ang implication yan guys, if you're the borrower, if you're the payer, no? If you're the one who loans, you would want the payment to be at the end of the period. So you'll okay, so depende din depende. Okay, any questions? 270,654, which is the same as a while ago. Ito 270. Ito, let me just increase the decimal places. Yeah, 270.654. Okay. Again, guys, requesting you to please chat if you're able to get the annuity due. Feel free to ask questions. Yes, thank you, Christine. Okay, waiting for the others. Okay, thank you, Fiona. Tyla, thank you. Yeah, very good. Okay, I'm still not getting 100% responses from you. Kamusta yung iba? Okay, good. Good. All right. Thank you, Bianca, Shiler, sino pa? Okay. Yeah, good. All right. I hope you're able to follow along, class. All right. So now let's compute for the future value this time. We can compute for the future value. Okay. But let me remind you about something here. Okay, so the payment is 30,000. So you have an annuity of 30,000. Let's make it at 12% para pareho dun sa and then years of payment 30. Okay, so what we want now is to get the future value. So this is 0, 1, 2. So this is 30K, 30K until year 29, year 30. So we have here 30K, 30K. The question is, how much is this now? Okay, what's the equivalent 30,000 annuity ordinary for 30 years at 12%? Okay, at 12%. How much is it after 30 years? All right, so the same thing. Okay, so I think this is a question of, if it's annuity ordinary, then we use the FB function. Okay, FB, but since your PMT is positive, this will return a negative answer, so I'll just put a negative there. What's the rate? 12%, comma. What's the NPER? 30 years, comma. What's the PMT? 30,000. Okay, comma, no present values, ignore that. Type is ordinary annuity, 0, or you can delete this. Okay, since that one also is 0, and you can ignore the zeros at the end. Okay, and then it will give us the same answer. All right, so the future value. Okay, so if you put money in an investment, 30,000 each year, 30,000 each year, okay, at 12% interest for the next 30 years, it becomes 7.239. Okay, because remember, this is what? Compounding interest on. Okay, annuity nga lang. Kanina yung compounding natin, it was just a single cash flow. Ito, it's an annuity. Okay, so if this was an annuity due, then this would be greater also. So rate is at 12%, NPER is 30, PMT is 30,000, no PV, and then the type is 1, because this is annuity due, and we expect the future value to be bigger. Control Enter. There. Okay, 8108, 8.1 million, greater than the annuity ordinary. Okay, so let me flush this. Flushing the formula for your reference. So this is ordinary annuity. This is annuity due. Okay, and then once again, guys, you know the drill. Okay, I'm going to request again for you to key in your responses if you were able to follow along. Okay, good. Thank you. Thank you. Okay, so several of you have already chatted. Let's give your classmates a few more seconds. Although unfortunately, I'm not getting 100% feedback from you. I hope the 22 students here will give their feedback, 100% of them, which means that you're able to follow along. Okay. All right, good. Thank you. Thank you. All right. Now, so you can reverse the process, guys. We can compute for the PMT. And this is the formula to compute for the PMT. Now let's see. Okay, let's do this. That's the next problem. So let me copy this formula here. Control C. Okay. So this time, okay, we're given the present value and the future value. Okay. And take, by the way, guys, by the way. Okay, I think I forgot to ask this. Okay. So how did we arrive at 7,239,8980? This is the future value of an annuity of 30,000 at 12% for 30 years. Okay, so let me draw that. I want to drive home a very important point here. Okay, so this one is 7.24 M. Okay, let me 7.24 M. This one is, it's a present value 241,655. Okay, and these ones are, so you have your 30,000. Okay, an annuity of 30,000. Okay, you have three cash flows here. This is the present value. This is 30K. This is 7.24 million. Take note that they're all equivalent cash values. Okay, so assuming that nothing extraordinary will happen with this cash flow, the rate is 12%. Okay, 30 years. The implication is that we are insensitive to whatever cash flow we're going to choose. If I choose 241,655 now, we're indifferent to choosing 30K for an annuity of 30K for the next 30 years, or we're indifferent to getting 7.24 million after 30 years. Why? Because these are all equivalent values. Only that they occur at different time frames. No? Yung 241,655, it's now. Yung 30, it's an annuity of 30,000 for the next 30 years. And then itong 7.24M, it's a one single cash flow at the end of the 30 years. Okay, but they're all equivalent. Okay, so how did we get 246,155? We used the 30K, diba? How did we use 7.24M? We used the 30K, right? So actually we can use 241,655 to get 7.24M. Okay, so let's do that very quickly. So just to show that 241,655 is equivalent to 7.24, so let me put here PV, and then FB. So our present value is equal to this one, 241,655. Okay, and then let's compound this and determine what will be its future value after 30 years. We should get 7.24 million. Okay, so let's do that. Negative FB. What's our rate? Our rate is 12%, comma. Our N per is 30, comma. We're not going to use PMT. We're going to use the present value of I wrote it here. Okay, I used the present value of 241,655. I copied it. Okay, and then since in this instance we're not using the PMT, we're not using the annuity, we're using this single cash flow now to compute for the future value, then the type remains irrelevant. So I'll just ignore that. All right. So you can see here that we were able to compute for the future value using the present value of 241,655. And you can also compute for the present value using 724. Okay, so I just wanted to illustrate to you that these three are equivalent cash flows. Magkakapareho sila. So ang equivalent ng 241655 sa isang annuity is 30,000. 30 years siya na at 12%. Ang equivalent ng 30,000 annuity for 30 years at 12%, after 30 years, it's now 7.24. But today, it's 24165. Okay? So, I hope that's clear, guys, yung equivalent factors. So when you compute for one value, you just use one. Dahil ang kino-compute mo si 30K. Either gamitin mo si 7.24 or si 241,655. You cannot use both, no? Kasi you're just they are equivalent cash flows. All right, sige, let's go here. Okay. Now let's compute for the PMT annuity. So we know either present value natin this one, future value natin 7.239, number of payments 30 years, interest rate 10%. So let's first make use of the, sige, ito muna, no? Yung formula muna. Okay, so let's use this, let's solve this all together. Okay, so we're going to use the formula. Hindi. Okay, mamaya na to. Kayo muna, guys, no? I want you to get the annual payment. So to get the annual payment, what will be our function? Kindly chat, please, in the chat box. What function are we going to use to compute for the annuity? What function? Anyone, please? Hello? Class, ano function natin? Anyone? How do we compute for the annuity? Okay, it will be my volunteer ba, class? Would like to compute for the annuity. Hello? Anyone, please? What function? You know that already. You know that. Makikita mo sa mga sa formulas ni Excel. It's what? It's annuity hinahanap natin. Therefore, PMT yan, guys. Diba? PMT. Kasi yun nga yung nakikita nyo sa mga sa syntax natin sa Okay, I'll give you 1 minute, please. Magta-time na tayo. Sana maabot natin isa. 1 minute, please, to work on the PMT. We expect 30,000. 30,000. Okay, so si Maxine gave I'm sorry, I think some of you don't understand Filipino. Okay, you have to remind me, class, because I tend to forget. So Maxine, what answer are you getting using the formula? But let's use the PMT function first, quickly. Class. So kindly use that and then tell us if you're getting 30,000. You have to get 30,000. 69,648. Okay, please review, Patricia, your formula. It has to be 30,000. Kindly chat, please, the answer that you got. But I expect you to get 30,000 because we already computed for that. One more minute, guys, and then let's discuss. Okay, no answer from the class? All right, sige, let's do this together. Okay, PMT. What's our rate? What's our rate, class? Oops, we have to change the rate here. We have to make it 12%, no? Just to be consistent. Otherwise, we'll get the wrong answer. Okay, 12%. So it's equal to PMT. Our rate is 12%. Our NPER is 30. Okay. Okay, what's our present value? Our present value is 241,655. Okay, comma. All right, since you already used the present value, don't use the future value anymore. Okay, otherwise, you're saying that these are different cash flows. These are just equivalent cash flows. So either use the future present value to compute for your PMT, or you use your future value to compute for your PMT. Okay, so let's just use the present value. So no future value and then comma, this is an annuity ordinary 0. And then I'm sure we'll be getting a negative answer. So let's put a negative there. There, 30,000. Okay. So here I use the present value. What if I use the future value? So I'll remove this, delete, delete, and then use the future value instead. A future value is 772. There. Okay, remember, guys, you cannot use both, no? Because you do not have actually you do not have 241,655 now, and then another 7,239 after 30 years. Okay, these are just one cash flow, either 241 now or 7,239 at the end of 30 years, or 30 annuity. Okay, so if we answer this, I'll get 30. However, if we include also the present value here, then we'll now get a different answer. 60 na kasi what we're trying to say is we have now 241 and then we'll have another 7,239 after 30 years. Okay, so parang dalawa na, no? All right. Okay, any questions? So let me just delete this. Okay. So that's 30,000. Okay, and then lastly, how about the formula? We have time for this one. So the rate is 12% times the present value. Okay, and then we divide it by 1 minus quantity 1 plus your rate is at 12%, and then we raise it, carry it to the negative n, and then close everything. There. And we should get, using the formula, 30,000. Okay, 30,000. All right. Okay. Okay, so let me stop recording now.